We can also use proportions to solve conversions between units, within a system, like within the imperial system or within the metric system, and also when we convert from one to the other. I know before what I did was the factor label method, but you can use proportions, mostly because these conversion factors here, these are actually ratios. These are actually ratios here. So I don't think they're necessarily rates. I don't think they're considered rates, but for now, who cares? They're ratios, so we can use proportions. As an example, let's suppose we want to know how many quarts there are in 35 cups. So we're going from cups to quarts, right? What's nice is if we use proportions, you can use cups to quarts. Where is that? You can use either one of these two. It doesn't really matter which one. I mean, the factor label method, it does, but here it doesn't. So what I'm going to use is the first one, right? So from the conversion factor here, we have 1 quart over 4 cups. That's kind of like our given one. The unknown, that's our x. We have the unknown number of quarts over 35 cups. And we set them equal. So let me say that again. The conversion factor, that's one of our ratios. For the other ratio, that's based on our unknown, right? We have 35 cups. The number of quarts is unknown, so we have this ratio. For the unknown, I'm using x. We set them equal to each other. And now we have to solve for x. And again, our wonderful units go bye-bye, right? You can cancel them off. And we get 1 over 4 is x over 35. And how do you solve that? Cross multiply. Cross multiply. Doing so, on the left we have 35 times 1. On the right we have 4 times x. And we want to solve for x, so we divide by 4. And as you can see, these cancel. And we get 35 over 4 is x, and that's just 8.75. So there are about 8.75, a little less than 9 quarts in 35 cups. Again, on an exam or whatever, I'll tell you how many decimal places to round to. The two decimal places I just chose kind of randomly. All right. I hope this makes sense, but I want to do another one. For this one, we have 320 fluid ounces equals how many cups? But again, if you went back to the table, let me do that. Fluid ounces and cups, we have this conversion factor, right? Or this one. And it really doesn't matter which one we use. You just have to be consistent with the units, right? So if I'm going to use the first one, let's say, that's what I'm going to use. Oh, wait, what am I doing? Come on. Okay. Sorry, I pressed the wrong button twice. Okay, so we want to be consistent with our units. So if I'm going to use the first one, right, 8 fluid ounces per cup. The other ratio, we have 320 fluid ounces, but how many cups do we have? So the number of cups is unknown. That's where the x comes in. So we have 8 fluid ounces per cup, right? That's from the given. From the question itself, there's 320 fluid ounces, but how many cups then do we have? That's the other ratio. They're both equal. We set them equal. And as before, cancel the units. Right? Again, you want the units in corresponding places. So they're both in the numerator for fluid ounces. Cups are both in the denominator, because now you can cancel. And this is what you get. You get this proportion. And as before, we cross multiply. Then we divide both sides by x. Excuse me, not x. What am I saying? We divide by 8. We get x equals 320 over 40. Excuse me, 320 over 8. And that's equal to 40. So there's about 40 cups in there. So again, we could have done this. We could have done this using the factor label method. You know, I just decided to use proportions. Now also, remember how last time I said you can convert between the systems, between the metric system and the imperial system? I did say that last time. And these are actually how you do it. You have these definitions. And of course, you can get the unit conversions. You know, we have for length, mass, and volume. Let's see. So let's say you want to convert from, let's say for this one, I was going to have everyone try it, but see, we're running out of time. Guess I'll have to do it with everyone. But let's say here we want to know how many inches there are in 10 centimeters. How many inches there are in 10 centimeters. So of course we want to compare them. So we have this here, the first row. And which either one of these, we can use either one. Okay, because we're going to use proportions. So what I did was, I used, I think it was the first one they had, but I used this one here. This is like our given, because that comes from the table. We have 10 centimeters. We don't know how many inches there are. That's our unknown. That's our x. It's almost like the blank here. You're setting that to be x. And as before, the units will cancel. That's how we get down here. And then you just cross multiply. Right? So from here, let me actually show the marking, so to say. Right? This unit cancels with this. This unit cancels with this. Even though this is inches, this is inch, that's okay. It can still cancel. And from here, we cross multiply. On the left, we have this product, 2.540 times x. And on the right, we have 10 times 1, which is 10. So then we divide, because we want to get x. X is our unknown. So we divide like so, and we get x equals this quotient. And that is what we're left with. Now, what questions do you have about this? Okay. So this is actually a word problem that I want to do. But here it's actually going to involve ratios. So let me see. We have like 30 seconds left. So I guess what I'll probably have to do is stop here, and we'll start from here next time. That's actually good, because then we can get the chapter